Coming up, I have a Technics STS-707, one of the more complex analog AM/FM stereo tuners. Analog as in analog reception, but it's still a digital front end. And I got no sound on this one. Let's check it out. What I have here is one of the finest AM/FM stereo tuners that has ever been built by any company. I'm talking the Technics STS-707. We saw one of these before that had a problem with the display, and that is not this one. If you go back and look at that video, it didn't have this big scratch on it. That one belonged to a customer. This one belongs to me. I just received this one. Fellow that gave it to me, I just fixed a couple of Blu-ray players for him. But this doesn't work. He thought it worked, but it doesn't. It has a problem. The problem it has is not the display either. The display works fine. The problem is there's no sound. I can tune the stations in, and what makes this tuner so good is the bandwidth. It has a wide and narrow, both the RF band, so you can put it on RF narrow or RF wide, and it also has IF band, wide and narrow. And it's got a signal meter, and as you can see, we're receiving a signal here, no problem. It's just there's no sound. There's no sound on AM, and there's no sound on FM. No noise, no nothing. So this one's got a problem somewhere in the receiver, and we're going to need to dig up a service manual or a schematic for this. I just so happen that I have a schematic, though, from the previous one. So I've taken it upon myself to print the full schematic out. I think the last time I just had the one page that had the power supply. In this case, I've got, I think it's pretty much all the schematic. There might be some that's missing over here, but it's got most of the schematic. I know it's tuning because I can see the signal meter, so I'm assuming that the problem has got to be probably on this side after demodulation. Anyway, we're going to have to use a scope on this one and figure out where we're losing our audio signal. So let's get started. Now that's a tuner. I know you guys are probably used to seeing, you know, a great big box with a little circuit board like this in it. Like that digital tuner I've got, it's got a little tiny board like that in it, right? And the rest of it's empty space. This one here actually has a lot of stuff in it. These are probably these are going to be the memory caps. What are they? They are 3.3 farads. 3.3 farad. They're only what, 2 volts? 2.3 volt. 2.3 volt, 3.3 farad for the memory backup. So no battery on this. And if we look at them here, they are right there. They are in series with each other. Right, so that's going to give it 4.6 volts total. And it's got a zener on here to limit the amount of voltage, otherwise the capacitors could go boom. But to get the voltage higher than 2.3 volts, they've put 2 of them in series. But that's not the issue. I just wanted to point that out. The 2 capacitors are in series. If you were to charge those things up, even at 2 volts, and short your screwdriver across it, you'd get a pretty good bang. Because you'd have many, many, many amps at 2 volts off of something like this, these super caps. Okay, first things first, we're going to dig into the schematic and start looking for signal. And we'll follow it through from one end to the next. The racket you hear going in the background, it was a bit chilly out today. The temperature has really dropped over the past couple days, and it's to the point where I've turned the heat on. So what I'm going to do is I'm going to let this place warm up just a little bit more, and then I'll turn the heat off so you guys can hear me without me competing for sound over the sound of the electric furnace that's going on behind me. It's 4.8 kilowatt, 240 volt. So it will heat this place up pretty quick. Now, I know the heat's still running. It'll go off. There it goes. Some of you may say, well, a tuner is just a tuner, right? Well, not exactly. You see, this thing here has got all kinds of cool circuits on here. It's a quartz lock system. It has a pilot bandpass filter and left sampling pulse, left minus 90 degree sampling pulse, right sampling pulse, and then a right minus 90 degree sampling pulse. So it uses all kinds of cool sampling and signal processing, and it basically eliminates the pilot by means of cancellation, which is really cool because you really don't need to use an MPX filter on a tuner like this, and there isn't one because that's all taken care of in demodulation. It's to say very, very, very complex, you know, by comparison to a regular analog tuner. This thing here is exceptionally complex. Right? FM oscillator 1/16 or 1/17, and I think this thing even can be programmed to do. This one's now set up for 89.7, but it looks like it'll, or 87.7. I think it can go down to 87.5 if you set it up accordingly. This one goes down to, I'm seeing where it goes down to right now. This one only goes 87.9, and I know it can go down lower than that. So to figure out how to do it, because my test transmitter is 87.7, but it says here that it can go down to 87.5 to 108 through the prescaler. There's got to be a way to adjust it. I think it's probably done by pushing buttons on the front panel, holding buttons down to change it. Probably puts it at 9 kilohertz. So I think there's a way to do that on the front panel too. But anyway, I know it's tuning signals in. I can see that showing up on the screen. So we have an audio problem on here. So I guess the first thing to do is we'll check for some voltages. So we've got our audio stages are over here. Composite signal, FM composite signal. Should go into, which IC is this? IC302. This is the peak sampling switch. So we should see audio signals. IC302. Where is 302? What's that? Oh, a hair. Looked like a piece of wire sticking there, but it's a hair. IC302 over here. IC301 is a flat pack on the bottom. So IC302, we can get at IC302, and we can measure it. I'm going to use my digital scope just because I hardly ever use it. I paid a lot of money for it and got to get some use out of it, right? Let's take a look. See what I see on here. So I'm going to look at pin number. Well, we'll look at pin number 1, IC302. We'll see do we have a signal going into pin number 1, and I'll show you guys. What I'm seeing here. Yeah. I know, boring, right? Boring. Not nice and cool like a CRT scope, but nevertheless, it's kind of useful. What's going on here? It's like this probe is not working. I should have audio there. I have audio. Why? This scope is a joke. Don't buy one of these scopes. You're wasting your money. Okay, I've got audio, as can be seen. That's pin 2 and there's pin number 1. So I've got audio getting into going into that IC. Where was I here? IC302, I think I said it was. Yes, IC302. This is a switch. This is the composite switch. So we follow the audio from here, and the audio signal will come out, and it goes into IC303, and it will come out pin number 14, and it goes into IC304, which is the decoder. Here's your separation adjustments over here. So let's check it. There's IC304. So let's check it on IC303. See if our signal is making it through IC303 and into IC304. I could probably just skip right to IC304 and see if I'm getting any signal there. Start at the end and work my way back. So IC304 is this one right over here. And we can look at pin 10 should be my, actually pin 9 should be my left plus right, so that'd be the mono signal, and pin 10 is going to be my left minus right. Looks like left minus 90 degrees plus right minus 90 degrees, so that's a phase shift here. Separation adjustment is down here. So anyway, we'll see a signal going in. We should see a signal going into pin number 10 right here. So pin 10 is, how many pins is this? 14? So 14, 13, 12, 11. Should be a signal going in there to pin 10, and there is indeed a signal going in to pin number 10. And this probe is still acting up. I don't know what the problem with this probe is. Junk. These are the probes that came with this machine here, but this scope is, let's just say it's frustrating. Maybe I'll use the Technics. This thing is, I'm not. It's a joke. Anyway, I see something there with my broken probe. So maybe it's time to start checking some voltages. As this should be this is pin number, this should be an output. I don't see any audio. I should see audio right there. And I'm not seeing audio, so I'm certainly not spotting what I expect to see. I should see audio here. And I'm not. Because that is, I'll show you where I'm looking. This is IC304. IC304, pin 10 is one of my inputs. Right? It goes in through pin 10, comes out through pin 8, back in through pin 12, and then it comes out pin 14, which is the right channel output. Pin 1 should be the left channel output. Its signal comes in through pin number 3, which is also fed off of pin number 9 over here, or fed off of the pin number 8 from IC303, which is over here. And if I look at IC303, audio signal. Yeah, something's fishy in here. Maybe we'll go back and spend some time looking at the power supply. Looks like I might be missing a voltage somewhere. So we'll go back to the power supply down here, measure some of the voltages. Q702, for example. Something's fishy. It's great to have such a complex piece of equipment until it doesn't work. Okay, so what are we here for? Transistors. I see, what is it here? Q705. Where is that? Q705, right here. Its FM is on, so it should have There's the power supply. 14.6 volts on the emitter on Q705. So the emitter has 14 volts. I'll show the meter so you guys can follow along at home. Q705 emitter has 14.2 volts, and the base should have 14.5, which 13.4 is good enough. Collector should be oh yeah, 14.5, 14.5. And then we look at Q702, which is, where is it? Where's Q701? Q702 here. Regulator transistor. Collector's got 19 volts on it. Looks right. Emitter should have 14.7. So let's look at the emitter, which is over here. 14.3. That's looking good. So that one's okay. That regulator's okay. Q701. Where's Q701? Over here. Q701 should have, looks like 9.9 on the collector. Yep, it does. The emitter should have 5.7, looks like. Yep, 5.7. So that one's working. So that one's good. And that one's good. Back over here, another regulator. Q701 and Q702 are regulators. They are, I got those, I checked those ones. So 702's got the right voltage, therefore 701's going to be working. We check 705. 705 is good. That one there. Where else is the next one I got to check here? This is switching for AM and FM. That's what these ones are for. These two. Where are we here? Where are we going next? Q905. What is this? What does this do? What does this one do? Looks like it should have 14.5. I guess it's, no, 5.7. That's connecting to the 5.7. So that's collector. Q905. Q905. Collector. 5.7. Okay. And the base should be 0.2. Which it is. And the emitter should be 0. Oh. 5.7 volts on the emitter. Why is that? That goes in and that feeds Q303. Where is Q303? Q303, where are you? I'm talking to the camera, by the way, not myself. Q303. Where is Q303, guys? Can you help me out here? Q303 is right here. Q303 should have 0, 0, and looks like 0.3, 0.8. 0.8 on the collector, 0 on the emitter, 0 on the base. So the base has 1.1, okay. The emitter has 1.8 and the collector has 0.7. The hell's this? What the hell is that? I think we may have found the problem. That looks like a piece of wire, just doesn't it? Oh, wonderful. Well, how did that get in here? That looks like a strand of wire. Let's power this thing down. Where'd it go? You guys see it? I'm sure it looked like a strand of wire. Where did it go? went back and looked at the footage, and when I was poking at it, it flew over here somewhere. So where the heck did it go? It's got to be over here somewhere. Oh, is that it? Is that it right down here? There it is. There it is. Where the hell? Let's get that out of there. Find something to pick that out with. It's right here. You can see it. See it there? There, look at that. Wet finger. Okay, so how the hell did that get inside here? I mean, you guys saw me open it. Well, I wonder if this thing works now or whether it blew something else up. Because that was lying right here in where Q303 is, which is, this is the muting control transistor, you see? Q303 is muting control. Q301 and Q302 are the muting transistors. And that's controlled from Q905, so I wonder if something got blown up. Let's just turn it back on here. Okay, I should have sound, but I'm not getting any sound. Let's go back and look at that voltage again. That Q905 was the one that the voltage was kind of screwy on. And I've still got 5 volts. So, I wonder if this transistor is shorted. Let's just check it and see. Q905. Emitter to base. Okay, that looks good. Okay, emitter to, our collector to base looks good. Emitter to collector is, yeah. That one is shorted, Q905. It looks to be shorted. I guess the only way to tell is to take it out. So to do that, I have to, I'm gonna lift the board out. Yuck. Gotta lift the board out on this one. Not looking forward to that. I gotta take out this board. Ugly. It's ugly. Okay, gotta pull the front face off for one. And I guess the red screws. Okay, well, I guess I have to start removing these red screws. Okay, one more here. Board should lift out. I may have to probably have to take the jacks off at the back. And the display comes out with it. So I gotta take off the front panel. I take out the screws on the front. Remove the screws on the front panel. Of course it won't lift off like that. That bracket off for the display. Now the front panel will lift off. And now I can lift the board. Well, I gotta take out a couple more screws on the back here. I gotta lift out these screws on the back panel. All to change one transistor. Okay. Board should lift out now. Okay, let's do this. Flip this out of the way. And lift the board up. Okay, now I can work on it. Now it's coming back to me of what I had to do on the last one of these. I turn on my iron and we'll take that transistor out and see if I can find a sub for it. Looks like the super cap is burned right off here, doesn't it? One of the terminals is. I guess the super cap is shot. So much for it maintaining the memory. You can can see the one lead here is burned right off on the super cap. This one here is probably also just about shot. I don't know if the caps are any good or not. They're probably no good because of the age. But for sure that pin is burned off. I mean, I could probably just replace this with a big 3300 or something, and it will hold the memory for a while. But obviously, to hold the memory for long term, I'd have to replace the super cap, which I don't have one of those things. I guess I could make an effort to go and get one, but that will mean taking this thing apart a second time to change it, which is not something that's high on my list of priorities for the little use that this tuner will actually get. I might be further ahead just to dial in the station I want to listen to when I want to listen to it, rather than put it all back together only to have to take it apart again to change the super cap. But you can see where it's been leaking on the board here, so I'm pretty sure that it's probably toast, and probably have to change one of these caps in the display circuit at some point too. But let's just see whether this will well, is the capacitor charged? Will it go bang? No. Of course not, because one lead is open. But whether this will resolder, or whether the board itself is toast, probably toast under here. Yeah, we'll just remove those. I'll replace them with a big regular cap that should at least hold the memory for a while, because this one here is, as you can see, the lead is burned right off of it. That one had a charge. That's what I mean. It's only 2 volts, but what a bang! So all the fun and games of blowing up that cap, we'll take it out. It should be dead now. It's not going to make any sparks now. So there's the dead. Well, this one's probably, well, we know this one still had some kind of a charge left in it. It's starting to blow too, right? It's starting to leak. I'm just going to, won't go bang, but you heard the good size bang from the 2 volts that was in here. I'm just going to, I'll put in place of it, I'm going to put just a regular electrolytic. Sure, it won't store the memory as long as these would keep the memory for years, right? But another one that I changed, a super cap for a regular cap. The old Sony receiver, I changed that like a year or two ago, and it's still holding the memory, believe it or not. The amount of power that the memory requires is minuscule. So let me get a regular cap on here, and then we'll check that transistor. I got a couple of 680 in parallel, which will give me like 1300 or so. 13 what? Anyway, we'll put these in here. Come on. Guess I'll just put it down that hole there and bridge it over below. This will be at least better than nothing. It'll hold the memory for at least a period of time. Let's just say this is not going to be a main tuner. Most of the time I'm not listening to radio, and if I am, it's off my digital tuner anyway, right? So I'll just hook that up there. I got to bridge it over to the trace that was eaten away. So I have to scrape that back a bit. As you can see, one trace here was kind of eaten away pretty good. We'll just scrape this back a bit and bridge it over to here. There we go. That ought to do it. Somebody's going to complain. I just know it. Keyboard warrior somewhere is going to squawk about me putting in the wrong capacitor, which they're going to say, you should have got the right one. You should have done this. I can do anything I want. It's mine, remember? And if I choose to sell it, oh well. Looks like this IC may have been changed at one time. Maybe that's where that strap of wire came from. Look at that. That looks like it's been changed, doesn't it? Maybe that's how that thing got damaged. I assumed that this unit had never been serviced because I got it from a guy that I used to work with, but For all I know, this may have come from second inventory, as the manufacturers used to blow stuff out, stuff that came back under warranty and was repaired. A lot of times, stuff ended up getting sold off from second inventory. So here's this transistor Q905. Just going to remove this one. That's this one here, I think. Yeah, that's the one. Okay, let's check it out again, and then I'll see if I can find one to replace it. So it was emitter to collector that it was shorting. So emitter, yeah, that transistor shot. Let me go find another one. I've got another one here, 2SC945. That's the same as the original that was in there. So let's just check this one out and see how this one looks. Good that way. And that junction's good. That junction there is good, and no short. So it's emitter collector base. Here's the or the tuner here. Emitter collector base. Now you see why I didn't want to have to take this apart again to change the super cap, because I would have just extended the wires and put them onto the board so I could tack one in on the top. That's all I would do, because I don't really want to have to take this thing apart ever again. Any of these units, you gotta pull the board out, or a pain in the butt. I gotta put the grounding screws in at least before I try it, because Panasonic are good at having multiple points on the board that are grounded through the chassis, and they're not grounded like from one point to the next. They actually use the metal box to ground the unit itself. Panasonic are very good at doing that, as we found out on all their plasma TVs that went kaboom when the ground screws came loose. And of course, Technics has Panasonic. That holds the display in place. Probably try it now. I think I got enough screws in now. I'll plug in the audio output. And
One I'm about to give you. If you think you know where we are, I need the name of the business and the exact address. If you're correct,
I got sound.
We'll give you $500.
Excellent.
If you're correct and you work there, double that amount of cash. This hour's clue, dirt enthusiast. The clue is dirt enthusiast.
Now there's no antenna on this.
Where we are.
Just to give you an idea how sensitive this unit is.
280-1011. Taking care of business. Powered by Applewood Auto Group. Only on Rock 101.
So it'll pull all the local stations in without an antenna. No problem.
Just unacceptable.
If I connect an antenna up to it,
I don't think so.
just a piece of wire, we'll see what it pulls in. And I love the display here. It tells you whether you've got interference above or below or on another adjacent channel.
Non-stop music.
Now with a real antenna on this thing, it's super sensitive.
Fights back, telling me that I'm ready. Past the forest of conscience.
Okay, well, I guess this one's
their jobs.
all ready to
For
go.
a closer look at the issue, we've reached Rachel Pulfer. She's executive.
Seems to be working. Haven't programmed much into it now. Just a couple stations. Anyway.
What they do at the park sheet, what they do is they have a carbon filter inside them, and when you fart, the carbon, it filters a gas out through it. So as it goes, your loved one's face beside you and has a little flatulence, little rumble, don't worry. You'll be all right. The air will be all nice and clean and smooth for you. And, was that 30 seconds yet?
No, keep going.
Oh, okay. Well, just in case, sometimes they can even get you the flower-scented one so that everything smells like roses for you and everybody there and there.
Now, I'm going to take it, not because you were overly entertained. I'm going to take it because I believe that's actually what it is.
Yeah, the sheets have carbon panels built into them to trap the nasty gas from the partners.
That's from the article. You were actually right.
Oh, right on.
The 2 to 6 thing with Tyler and Lynch. See, Fox.
Okay, well, I think this one's all done. So thanks for watching. We'll catch you in the next one. Bye.